the load resistor removed. You understand what I've said? That means we have removed load resistor here, right? So these two will be disconnected terminal by then. Okay, let's draw the circuit. There is a source, there is a resistor, okay, then there is another resistor, then another source, and that is where the load resistor are connected. This is where the load resistor are connected. So our first job is removing the load resistor. I have removed it, right? So there is no load resistor by now. Load resistor is removed, disconnected, right? Now, second job is measure voltage between disconnected terminal where from the load resistor removed. That means which one? This one and this one. That means you can mark is A and B. These two are the disconnected terminal of the load resistor. So now place and measure voltage. So how would you measure voltage? Placing a voltmeter, right? Yes. So if you place a voltmeter here, we will see ETA is a voltmeter. You understand?
Yes.
Huh?
No, sir.
Sorry? You don't understand?
No, sir. No,
The first job, okay, finding ETAs is our job. Okay. So ETAs, the first, we'll find ETAs is the effective potential of this circuit due to many other sources, and that can be found across the load resistor.
Across?
Yes, where the load resistor were placed. You understand?
Yes, sir.
So first, okay, I'm telling you what. Maybe he is somebody, his father's son, right? So how much his father loves him? How to find it? First, remove him. I mean, take him maybe. What? Kidnap. And then what his father is doing, just to find it. That's what will
how
be.
Much money his father will give?
His father's reaction. Or love across him.
He is
Do you understand? He will never say that I have another son. Doesn't matter, right? Okay. Once there is a person who lost his son, so he has got a relative. That relative didn't come in that. What I call.
You don't know. This place or kingdom.
Anyway, no. One person has got two sons. So one son is died somehow, and the relative, one of the relatives, he didn't come on that. He didn't come on that, right? So as he didn't come, are we running out of time? No. So listen. So once that relative didn't come, right? What happened? He's like giving you, why didn't you come? My son was killed or somehow something happened. Died. So then he is giving him some condolence. Okay, I'm sorry, but next time when is your next son is died, I'll come. So that is how it's happening. Okay, listen. Next to that is, so do you understand how we measure? So first remove this load resistor, because anything applied due to the force, the overall force due to both of the sources were applied across the load resistor. So first remove your load resistor, and now place something that can count that how much effect, how much force there is. So that is the voltmeter. So place a voltmeter that will count due to both of the sources what is the effective potential applied here. That is the Thevenin's equivalence potential. You understand? So that's the theorem board. That's it. Okay, so we can easily find out this, right? So next one is finding RTS. RTS is, first thing is what is that? Okay. Remove the load resistor. That is the first job. So both places you have to remove the load resistor. Okay. And next to that is can you tell what is next?
Sir, finding the
Can you tell it?
sir, resistance across the resistance.
Can you tell what is next? You can easily tell that what is next. I'm asking what? Can you tell what is next? Oh, you would say yes, sir. I can tell what is next. Very easy, right? She even cannot tell what is next. So how are you talking? Okay. So next to that is listen. Next to that is okay. Make the voltage source with a short circuit. Short circuit. And if it is a current source,
Open circuit.
okay. We can open, right? You understand?
Sir.
So now, then just measure resistor. Measure resistor. Total resistor. Resistor between where? The same thing. Disconnected terminals where from the load resistor removed. You understand? Is that clear? So at any complex circuit there will be only one load resistor. So you will operate whatever, maybe there is thousands of resistors, thousands of voltage source. You do not need to count that either this is the positive of the source. We counted it, right? While we solved the Kirchhoff's voltage law problems, then we count that this is positive to negative, that is plus, then negative to positive, that is minus. We do not need to count. There might be thousands of sources, but we just have to work on the load resistor, right? So that is why how this law is easy. This law gives you an easy solution. Okay. Now, say measure voltage between these two terminals. Now we'll measure resistance between these two terminals. Right? So now the circuit will look like, as it is a voltage source, it will be a short. So that is the disconnected terminal. Now is it okay? Now place a ohm meter, right? To measure the resistance here between these two terminals. Is that okay? Huh? Is that okay?
Sir, resistance को sir.
Sorry? This is the resistance, this is another resistance, and we are placing ohm meter between the disconnected terminal. This was the disconnected terminal of the load. There was a resistance. Compare this one. We have first short these two because these two are voltage source. We have shorted these two. And next to that, we have removed RL and placed an ohm meter here. Is that okay? Huh? So that's how you can measure RTs, right? And the total current is equal to VTS over RTs. Is that clear? Yes. That's all. Okay, let's do this for now.